All right, so this will be the very end of section 5.2, and there's only 10 or so problems left, so it should go kind of quick. And the problems really aren't really different than what we did in problems 1 through 10. They're just asking a little more of us. So if I just glanced at problems 11 and 12, they both give me functions that are polynomials, actually cubic polynomials, and looking at those functions by themselves, I'd have no idea what to do. So let me look at the instructions, because that's going to tell me what to do. So part A for each one of these says use your graphing calculator or the rational root theorem. I'm just going to cross this out because we're not going to use this. We're going to use our graphing calculator to find an x-intercept of the polynomial. And then it says you'll need to find one x-intercept for a third degree polynomial. You'll need to find two x-intercepts for a fourth degree polynomial. So I can certainly do that. So for problem 12, part A, I just need to find one x-intercept. There's probably going to be three x-intercepts, because a function that has an x cubed can have as many as three x-intercepts. It could have as few as one. But I need to find any x-intercept. And how am I going to find it? I'm going to find it by graphing. There's a way to find an x-intercept without graphing using the thing that I scratched out called the rational root theorem. But it could take as much as 15 minutes to find one x-intercept. And it's not really a very productive way to find an x-intercept. So I'm going to find an x-intercept by just entering x cubed plus 8x squared plus 11x minus 20 on my calculator. I'm going to graph it. It crosses the x-axis 3 times, so there's 3 x-intercepts. I need to find any one of the 3 x-intercepts. It doesn't matter which one that you choose. I like using positive x-intercepts as opposed to negative, so I'm probably going to try to find that x-intercept as opposed to those x-intercepts that are negative. And I find them exactly by just going second in table and looking for a point that has 0 in the y column. And there's an x-intercept. It's the point 1, 0. Now I am done with part A. I found an x-intercept. There are definitely more x-intercepts. If I went backwards, I'd see there's negative 4, 0 and negative 5, 0. Those would also be correct answers to 12A. It's going to be important to remember that an x-intercept of 1, 0, algebraically, you'd been solving a problem that said x minus 1 equals to 0. Because to get an x-intercept, you take factors and set them equal to 0. And the simplest factor that would give you an x-intercept of 1 is x minus 1 equal to 0, because you'd add 1 to both sides and get x equal to 1. That's important because that's going to help us do 12b. 12b says use synthetic division to completely factor the polynomial. Then it says use double synthetic division for fourth degree polynomials. This is a third degree polynomial. I just need to do synthetic division. Synthetic division that gives me a remainder of 0, teaches me how to factor something that I might not naturally be able to factor. So I'm going to take the initial polynomial and I'm going to divide it by the factor that would generate the x-intercept. In that case, this case, x minus 1. So I'm going to do this in synthetic division. So the x-intercept gives me a factor. You can just say the x-intercept was x equal to 1, and I'd minus 1 from both sides. That would give me a factor of x minus 1. So one of the factors of x cubed plus 8x squared plus 11x minus 20 is x minus 1. Let me do the synthetic division here to figure out the answer. So I'm going to put the x-intercept, or change the sign of that number and put it in a backwards bracket, and then write the coefficients 1, 8, 11, and minus 20 above a line. Leave myself some room and do the synthetic division. So I just peeled off the coefficients, change the sign just like we did for problems 1 through 10. I'm going to bring this number down, and then I multiply 1 times 1 and get 1. These numbers have the same sign, so I add. I multiply 1 times 9 and get 9. I add and get 20. I multiply 1 times 20 and get 20. Because these numbers have opposite signs, I subtract. And this synthetic division answer tells me that the answer to synthetic division is 1x squared plus 9x plus 20 with a remainder of 0. So I'm going to write the answer to this division problem is x squared plus 9x plus 20. Well, I know from doing my synthetic division that if I get a remainder of 0, that the denominator times the answer equals the function. So the original function was f of x equals x cubed plus 8x squared plus 11x minus 20. The synthetic division, because I got a remainder of 0, tells me that this factors into x minus 1 times x squared plus 9x plus 20. So synthetic division with remainder of 0 gives us a tool to factor a polynomial. Part B says use synthetic division to completely factor the polynomial. Synthetic division really only gives you a partial factoring of the polynomial. To completely factor the polynomial, I have to do some work by myself. This second parentheses right here is going to factor, and when I factor it, it's going to give me the answer to part 12b. So I'm going to write f of x equals x minus 1, and I'm going to factor this into x plus 4 times x plus 5. That would be considered taking the initial polynomial, using synthetic division to partially factor, and then finishing up by completely factored. My answer for 12b needs to have the polynomial factored as much as I could factor it. Done with 12b, moving on to 12c. 12c says solve f of x equal to 0. Well, for 12c, most of the work is done for me. The problem says set f of x equal to 0. Well, I could set f of x equal to 0 by going x cubed plus 8x squared plus 11x minus 20 set equal to 0, because that's certainly setting f of x equal to 0. I'd have no idea how to solve that. So I'm going to replace f of x by another thing that it's equal to. I'm going to replace it with x minus 1 times x plus 4 times x plus 5. So I took the initial question, changed it, the function notation that was given to me, then changed it to the function notation that I found in 12b. Now this is easy to find the answers to, because if something's factored and set equal to 0, you could just separate each of the factors and set them equal to 0. This first factor is going to give me an answer of x equal to 1. The middle factor is going to give me an answer of x equal to negative 4. And the far one's going to give me x equal to negative 5. It doesn't ask me to find x-intercepts, so I don't have to write this as a point 1, 0, negative 4, 0, negative 5, 0. It's just asking me to find the values of x that are solutions to that equation. Graphically, they turn into x-intercepts, but for my answer for 12c, I don't have to write them as an x-intercept. If you wrote these as x-intercepts, I completely live with that. It's just not, it didn't say find the x-intercept, so I don't need to write these answers as points. But I'm going to write x equals 1, negative 4, and negative 5. Let me help you get started with 11. The first thing in number 11 you're going to do is part A. And part A wants me to use my graphing calculator to find any one of 3 potential x-intercepts. So to do that, I'll turn my calculator on, hit y equals, clear the old function, and go x cubed plus 2x squared minus 5x minus 6. Graph it. Has 3 x-intercepts. I like to find the positive one. I'm going to go second in table, and look, there's an x-intercept of negative 3, 0, negative 1, 0. Those are fine x-intercepts, but I like the positive one. I would use the x-intercept of 2, 0. It's easier for me to use. So my answer to 11a, I need any one x-intercept. I could use one of the other 2's x-intercepts, but I'm going to say my x-intercept is the point 2, 0. Done with that, but remember, an x-intercept of 2, 0 would come from a factor of x minus 2, because if you set x minus 2 equal to 0, if that's one of the factors, you'd get x equal to 2. So in 11b, you're going to need to do synthetic division. And you're going to divide your polynomial x cubed plus 2x squared minus 5x minus 6 by x minus 2 using synthetic division. For the synthetic division, you're going to take the x-intercept or change the sign of that, put it in a backwards bracket, and go 1, 2, -5, -6, and then bring down the 1, multiply and add the whole way. The answer to this is going to be what you're going to put there once you throw the x's in, and it's going to teach you how to factor that. So that should get you started anyways. You still have the rest of B to finish up and part C. If you can't do B and C right yet, watch me do 14, and it should walk you through it just fine. So 14 is a little tougher because there's a 2 in front of the cube term. But for 14a, I'm going to use my calculator to find any one of potentially 3 x-intercepts. So I'm going to enter the function y equals 2x up arrow 3 minus 5x squared minus 4x plus 12. Graph it. There's kind of 3 x-intercepts. Let me try to find them. Second table. I see immediately that 2 again. So I'm going to use the x-intercept of the point 2, 0. And remember, the factor that I'm going to have to divide by is going to be x minus 2. Because the factor of x minus 2, if you set it equal to 0, you'll get x equal to 2 and it turns into that x-intercept. So for part B, I need to do my synthetic division. And I'm going to divide 2x cubed minus 5x squared minus 4x plus 12 over x minus 2, and that's going to have a remainder of 0 because it's an x-intercept. And let me do that. I'm going to put a 2 here and then go 2, -5, -4, positive 12. Bring down the 2, multiply, and then -5 plus 4 is -1. 2 times -1 is -2. Here the numbers have the same signs, so I add them and keep them negative. And then 2 times -6 is -12. You get a 0. So this is going to give me 2x squared minus 1x minus 6, remainder of 0. So the answer to this division, the original polynomial divided by x minus 2, gives me 2x squared minus x minus 6. And what does that tell me? It says the initial problem, 2x cubed minus 5x squared minus 4x plus 12 equals the denominator of that fraction that I created times the answer to the synthetic division. This is considered partially factored but not completely factored, so I'm not ready to call this an answer to part 14b. To finish up problem 14b, I need to factor this. I'm going to do bottoms up on the side here. So I'm going to bottoms up factor that. And the first thing in bottoms up I'm going to do is I'm going to multiply by 2 and rewrite. That's going to give me x squared minus x minus 12. And then I'm going to factor. This is going to factor into x plus 3 times x minus 4. And then I'm going to divide by 2, reduce, and bottoms up. So divide that by 2, that by 2. This one I bottoms up the 2 and get a 2x plus 3. This one I divide 4 divided by 2 and get x minus 2. So I'm going to replace this with that. So I'm going to say a potentially good answer would be f of x equals x minus 2 times 2x plus 3 times x minus 2. It probably would be better if I wrote this as x minus 2 squared. So for my 14b, my answer, I might say f of x equals x minus 2 squared times 2x plus 3. So x minus 2 has even multiplicity. This is why the graph touched the x-axis and didn't cross the x-axis. It gave me a turning point. Done with part B, moving on to part C. Part C wants me to solve f of x equal to 0. So for 14c, I want to solve f of x equal to 0, or the original function 2x cubed minus 5x squared minus 4x plus 12 equal to 0, or better yet, x minus 2 times x minus 2 times 2x plus 3 equal to 0. And each one of these has the same answer. This one's the easiest one to get the answer for. So I'm going to go x minus 2 equal to 0, x minus 2 equal to 0, and 2x plus 3 equal to 0. These first two give me answers of x equal to 2. And the last one, I'm going to minus 3 from both sides and get 2x equal to minus 3, and then divide both sides by 2 and get x equal to minus 3 halves. For my answer to 14c, I don't need to write these as x-intercepts even though they are. I'm just going to write x equal to 2 and negative 3 halves. I'm not going to write the 2 twice, but it would be fine to write it twice. I'm not going to write them as an x-intercept, but it would be okay to write them as an x-intercept. So your problem 13 should also have bottoms-up factoring after you do the synthetic division. So first step, graph the function, y equals 2x up arrow cubed minus 13x squared plus 24x minus 9. Graph it. It has a touching one, that's an even multiplicity. So anyways, I need an x-intercept. So I go second table, and immediately I see 3, 0. So I'd probably use x equal to 3 for my answer to 13a. And when you go to do part 13b, you're going to divide your polynomial, move that 3 over, you're going to divide it by x minus 3. You're going to put 3 in the backwards bracket, and then do 2, negative 13, 24, negative 9. You'll get a remainder of 0 that will help you factor the initial polynomial. All right. The next problem is a 4th degree, which we have to do double synthetic division, and I've never put a double synthetic division problem on a test, so don't freak out too much about this. But the last 3 problems are double synthetic divisions. I don't want 3 double synthetic. I want one more easy problem. Let me change our problems so that we have one more cube, because I don't think we've done enough cubes yet. So let me make a problem up real quickly here for both of us. So let's change your problem into, I'll make sure it's not the problem that we've just done. It's not that problem. And that doesn't look like any of the problems that we've done so far, I don't think. Doesn't look like it. So let's change problem 15 to be f of x equals x cubed minus 5x squared minus 4x plus 20. And I'm going to change my problem to f of x equals x cubed minus 3x squared minus 4x plus 12. I'm gambling that both of these work, and it's so dangerous making up a problem on the fly. Let me do your problem 15, and I'll never do 16, but I'll change it for us. So let's walk through 15. If you can do it without me, pause the video and do it. So 15a, I need an x-intercept. So for problem 15, I'm going to enter the function x up arrow 3 minus 5x squared minus 4x plus 20. Graph it. Has 3 x-intercepts. I just need any positive x-intercept. I could use the negative 2, but I'm going to use but use positive 2 so much. Let me use 5. So 5, 2, and 5 is an x-intercept, 2 is an x-intercept, negative 2 is an x-intercept. Let me use the x-intercept of 5, 0. That's all I need to do for part A for all of these problems. and a third degree polynomial is just find one x-intercept. And again, that algebraically would come from a factor of x minus 5, because if you had a factor of x minus 5 and you set it equal to 0, it would give you an x-intercept of 5. So for 15b, this is my synthetic division and factoring, I'm going to divide x cubed minus 5x squared minus 4x plus 20. I'm going to divide it by x minus 5 using synthetic division. Because I'm using an x-intercept, I'm going to get a remainder of 0. I'm going to change the sign of the denominator. I use the sign of the x-intercept, put it in my backwards bracket, and then have a 1, a negative 5, a negative 4, and a 20. Bring down the 1, multiply 1 times 5, and I get 5. Negative 5 plus 5 is 0. 5 times 0 is 0. Negative 4 plus 0 is negative 4. 5 times negative 4 is negative 20. Gives me a remainder of 0. So this is really going to give me 1x squared plus 0x minus 4, remainder of 0. And so what this division gives me is just x squared minus 4. I don't need the 0x, nor do I need the remainder of 0. And what does that tell me? That tells me that the initial function, x cubed minus 5x squared minus 4x plus 20, it factors into the denominator times the result of the synthetic division. That's partially factored. I'm going to completely factor it by just factoring that. My answer to 15b is just going to be f of x equals to x minus 5, and then x plus 2 and x minus 2 for the factoring of the x squared minus 4. Done with part B. Part C wants me to find f of x equal to 0. So when I go to do part C, if I try to solve f of x equal to 0, since f of x equals to that, I might as well just set x minus 5 times x plus 2 times x minus 2 equal to 0. Then I would go x minus 5 equal to 0, x plus 2 equal to 0, x minus 2 equal to 0. The first one will give me x equal to 5. The middle will give me x equal minus 2. The last will give me x equal to 2. So my answer is going to be x equal to 5, negative 2, and positive 2. All right, so I'm going to do one of the two fourth degree ones, maybe not both of them. And so it's okay if you pause the video, stop the video now, and don't do the fourth degree polynomials. You have to do double synthetic division for it. It's not going to be on the test. I'll show you one double synthetic division in case you have the desire to learn it. I don't think you'll see it in another class. Andrew McIntosh sneaks a single synthetic division into some of his calculus classes, but I haven't seen him do a double. So let me do 18. Let me do 18a. Find it, since it's a fourth degree polynomial, I need two x-intercepts. So I'm going to enter the function 4x up arrow 4 minus 15x cubed minus 8x squared plus 15x plus 4. I'm just going to go straight to the table, and I see an x-intercept at x equal to 1 and 4. I need any two x-intercepts to get started here, and I'm going to do double synthetic division. The x-intercept of 1 would come from a factor of x minus 1, and the x-intercept of 4 would come from a factor of x minus 4. So this is my answer for 18a. I'm going to say the two x-intercepts are 4, 0, and 1, 0. Notice I keep dragging out the positive x-intercepts. I ignored that negative 1 x-intercept. I only need two of them. If there's positive ones, I'm going to use the positive ones. When I get down to 18b, I need to do synthetic division, and I'm going to do twice synthetic division. The first synthetic division I'm going to do is by either of the factors. I wrote 4 on top. I'll do the 4 first. I'm going to do 4x to the 4th minus 15x cubed minus 8x squared plus 15x plus 4, and I'm going to divide it by x minus 4. And I'm going to put a 4 in a backwards bracket and then peel off the coefficients. 4, negative 15, negative 8, positive 15, and 4. Bring down the 4. Multiply 4 times 4 and get 16. These have opposite signs, so I subtract and take the sign of the larger and get 1. And then 4 times 1 is 4. Negative 8 plus 4 is negative 4. 4 times negative 4 is negative 16. 15 minus 16 is negative 1. 4 times negative 1 is negative 4. Then I get a remainder of 0. Now I'm going to do a second synthetic division with the factor of x minus 1 and the numbers from my answer other than the remainder. So I'm going to do a second synthetic division with the numbers 4, 1, negative 4, and negative 1 with the second x-intercept of x minus 1 using the answer from my first synthetic division. This is why I call it double synthetic division. First one I did with the x-intercept of 4, 0. Second one I'm doing with an x-intercept of 1, 0. So I'm simultaneously first dividing the function by x minus 4 with the first synthetic division, and then I'm dividing by x minus 1 with the second synthetic division. So let me do this synthetic division. I'm going to bring the 4 down. I'm going to multiply 1 times 4 and get 4. And then 1 plus 4 is 5. And then 1 times 5 is 5. Negative 4 plus 5 is 1. 1 times 1 is 1. This is 0. This is going to be 4x squared plus 5x plus 1, remainder of 0. And what this tells me is doing this double division, taking the fraction 4x to the 4th minus 15x cubed minus 8x squared plus 15x plus 4 divided by x minus 4 times x minus 1 equals 4x squared plus 5x plus 1. When you do double synthetic division, the two factors in the denominator times the answer equals the numerator. So what this tells me is that the numerator, 4x to the 4th minus 15x cubed minus 8x squared plus 15x plus 4 equals to x minus 4 times x minus 1 times 4x squared plus 5x plus 1. This is considered partially factored. So in part B of number 18, I'm supposed to completely factor. This isn't completely factored because that 4x squared plus 5x plus 1 likely factors. I'm going to do the bottoms up factoring for that. So I'm going to bottoms up 4x squared plus 5x plus 1. I'm going to multiply by 4 and rewrite and get x squared plus 5x plus 4. Then I'm going to factor that into x plus 1 times x plus 4. And then I'm going to divide by 4, reduce and bottoms up. So the 4x squared plus 5x plus 1 can be replaced with 4x plus 1 times x plus 1. So my answer that I'm getting ready to write for part 18b is going to have 4 factors because it's a 4th degree polynomial. 3rd degree polynomials usually have 3 factors. 4th degree polynomials usually have 4 factors. And I'm going to say the function f of x is going to factor into x minus 4 times x minus 1 and then times 4x plus 1 times x plus 1. Completely done with part B using my double synthetic division. Moving on to part C. Part C says solve f of x equal to 0. So I'm trying to find f of x equal to 0. I might as well take the factored version of f of x and set it equal to 0. So I'm going to go x minus 4 times x minus 1 times 4x plus 1 times x plus 1 equals to 0. I'll go x minus 4 equal to 0. That will give me x equal to 4. X minus 1 equal to 0. That will give me x equal to 1. 4x plus 1 equal to 0. I'll minus 1 from both sides and get 4x equal to minus 1. Then I'll divide both sides by 4 and get x equal minus 1/4. And the x plus 1 equal to 0, you get x equal to negative 1. So my answers for 18C, there's going to be 4 of them. It's going to be x equal to 4, 1, negative 1/4, and negative 1. Again, you're not going to be responsible for double synthetic division on the test. So if you give 17 a try, that's completely awesome. If you don't, it's okay. Similarly, if you give 19 a try, you're going to have to find two x-intercepts, and you're going to have to think of this as x to the 4th plus 0x cubed plus 7x squared plus 0x minus 8. When you do the synthetic division, if you do problem 19, you need a placeholder for every power of x, and it's missing an x cubed and x to the first power term, so those need to be inserted if you want to do the double synthetic division for them. Okay, that should be enough.